Topic of this video is EX1, which is I can apply the rules of exponents to simplify exponential expressions. Going along with this video is the practice worksheet. The front of the practice worksheet you'll fill out as we work through some problems together, and then the back, some individual practice that you will do on your own and then come check with me. Just a quick review of the basic rules, the first one being the product rule. Product meaning we are multiplying together two powers, meaning two expressions with exponents. If you are having a hard time keeping these straight in your mind, remember you can always write the expressions in expanded form. So x times x times x times x times x, 5 factors of x times x times x times x times x, which is just x to the 8th. The rule being that we add exponents. So in that product rule box at the top of your paper, I would like you to do this problem right now. You can pause and then come back. Hopefully you did that problem, and hopefully it was the same problem. Yep. Y to the third times y to the fourth. You do not have to expand it out, but if you're consistently missing these, go ahead and expand it out. Y to the third times y to the fourth is y to the 7th. Second main rule is the quotient rule. Again, we can expand that out. X to the 5th is x times x times x times x times x. X squared is x times x. We can cross out two pairs of x's because x divided by x is 1, x divided by x is 1, which leaves us with x to the 3rd. The rule is that you subtract the exponents. The problem I'd like you to do in that quotient rule box on your extra practice worksheet is x to the 8th divided by x to the 3rd. Go ahead and press pause. All right, hopefully you did that problem and you got x to the 5th. Again, expanding is optional, but we have 8 factors of x on the top divided by 3 factors of x. Crossing out 3 of those pairs, we have x to the 5th. The power rule, our third main rule, x to the 3rd squared. This is what we were calling partially expanded form. X to the 3rd squared is x to the 3rd times x to the 3rd. Of course, you can always go ahead and fully expand that. And x to the 3rd squared is x to the 6th, with the rule being that you multiply the exponents. Go ahead and on your paper do x to the 5th raised to the 4th power. Push pause and then come back to check your answer. All right, so hopefully you did that problem and you got x to the 20th. You can write it in partially expanded form, x to the 5th times x to the 5th times x to the 5th. You could even fully expand each of those x to the 5th factors, writing x down 20 times on your paper, but hopefully at this point that is no longer necessary. Fourth major rule is when you have a 0 exponent, that part of the expression always equals 1. So it doesn't matter what's happening inside these parentheses. The whole thing is raised to the 0 power, which means it equals 1. Anything to the 0 power is 1. If you're looking at this one, this is the little bit of a trickiness, is that in this expression, 25 is not being raised to the 0 power. So we have 25 times 1 times 1 times 1, which just equals 25. There's no place for this on your paper. You're just following along. I wanted to contrast that with this expression where we have a base of 25x raised to the 0 power. So in this case, we do have 1 times 1 times 1, which just simplifies to 1. Last major rule, which is the one that most of you are having issues with, those of you that are having issues, and that is the rules relating to negative exponents. So if the negative exponent is in the numerator, or if there is no denominator, meaning the denominator is 1, the rule is that you make the exponent positive and move the expression to the denominator. This is where we've been doing a lot of these little these little arrows signifying, hey, x to the negative 3, we're going to take that down to the denominator, and that just by the definition and by the pattern of negative exponents is 1 divided by x to the third. Same thing here, but the 4 is not being raised to the negative second power. So we just have 4 divided by x squared. The reason the 4 is not being raised to the negative second power is that order of operations, we do exponents and then that implicit multiplication. Did we just do this? Oh, no. Okay, if the negative exponent is in the denominator, we still make the exponent positive, but now we move the expression to the numerator. So we have 1 divided by x to the negative 5th. That becomes positive, and we have just x to the 5th. You could put it over 1, but that's not necessary. 1 divided by x to the negative 5th is just x to the 5th. Same thing happening here. The 4 stays below, and we have x to the 3rd divided by 4. The arrows are really helpful. Okay, now on your paper there are 6 entries in a table of 6 different negative exponent problems that I'm going to have you go ahead and simplify. So I'll show you a problem like this one, x to the 3rd divided by x to the negative 1. I want you to write that on your paper and then press pause, and then you'll come back. Okay, so hopefully you simplified that expression to a final answer of x to the 4th. The x to the negative 1, we take our arrow, we move that up to the numerator, so we have x to the 3rd times x, or times x to the 1st, which by the product rule is x to the 4th. Next problem, which you're going to write on your table, x to the negative 6 divided by x to the 4th. Press pause. Okay, hopefully you have a final simplified expression of 1 divided by x to the 10th. Again, with our arrows, it's x to the negative 6 that's going to the denominator. The x to the 4th stays put since it's positive. And now we have 1 over x to the 4th times x to the 6th, which is just 1 divided by x to the 10th. Third problem, x to the negative 2 divided by x to the negative 5. Press pause. Coming back, I hope you have a final answer of x to the 3rd. We moved the x to the 5th to the numerator, the x squared to the denominator, giving us x to the 5th divided by x squared, which by the quotient rule is x to the 3rd. You could have used the quotient rule for all of these, meaning we subtract the exponents. X to the 3rd minus negative 1 is x to the 4th. X to the negative 6th minus 4 is x to the negative 10th, which is 1 over x to the 10th. And x to the negative 2 minus negative 5 is x to the negative 2 plus 5x, x to the 3rd. But most people that are just trying to use that quotient rule are subtracting their integers incorrectly. So I would really suggest that if you are not getting these correct, that you go with the arrow approach and move the negatives. All right, 4th entry on your table. Now we have 2 variables, x to the negative 2, y to the 4th divided by x to the 6th, y to the negative 3. Write that on your paper and press pause. Coming back, I hope you have a final answer of y to the 7th divided by x to the 8th. Again, I am suggesting the arrow approach, so you take the x squared down to the denominator, the y to the 3rd up to the numerator, and then we have y to the 4th times y to the 3rd, which is y to the 7th, divided by x squared times x to the 6th, which is x to the 8th. Next problem. X to the 9th, y to the negative 1, divided by x to the negative 1, y to the negative 5th. Press pause. Hopefully your final simplified expression is x to the 10th, y to the 4th. Using our arrows, we just move x to the negative 1. Oh, we move a lot. Y to the negative 5, and y to the negative 1 goes to the denominator. That leaves us with x to the 9th staying put in the numerator. X to the 1st went up to the numerator. Y to the 5th went up to the numerator. And y to the 1st in the denominator. This leaves us with x to the 9th times x to the 1st, which is x to the 10th. And then y to the 5th divided by y to the 1st, which is y to the 4th. Last problem in this section. Okay, x to the negative 2, y to the negative 5 divided by x to the negative 5, y to the 7th. Press pause. Final answer, x to the 3rd divided by y to the 11th. Again, a lot of arrows happening here. The y to the negative 2 numerator, y to the negative, or to the denominator, y to the negative 5 goes to the numerator, y to the negative 4 to the denominator. So we are left with only in the numerator x to the 5th, x squared, y to the 7th stays in the denominator, y to the 4th is moved to the denominator, leaving us with x to the 5th divided by x squared, which is x to the 3rd, over y to the 11th. Those are our 5 main rules: the product rule when you are multiplying powers, the quotient rule when you're dividing powers, product rule add, quotient rule subtract, the power rule where your base of a power is another power, we multiply, then we have the 0 and negative exponent rules. When we are looking at a more complicated expression in which you apply more than one rule, here's my suggestion, just for a strategy as to how to tackle it. Use the power rule first, multiplying the exponent to each of the bases. Move around your negatives using that arrow strategy, and then simplify your final expression. Okay, so this example, you're just watching. You don't write this on your paper. Okay, so we are applying this negative 3 exponent to each and every one of the factors within that product. So we have negative 2 to the negative 3rd. Why did I put that in parentheses? Sing it for me. Negative bases must be in parentheses. Oh, that's not right. X to the negative 2 times x to the negative 3 is x to the 6th. Y to the negative 3rd, and then z to the 5 times negative 3 is negative 15th. Let me check that. Yes, yes, yes. And so this y that doesn't have an exponent, just it has an invisible exponent of 1. So you can still think of multiplying or just applying that exponent of negative 3. Okay, now let's use a different color for our arrows. This is going to the denominator, so is this, and so is this. So we have only in the numerator x to the 6th, everything else had a negative exponent. So we have negative 2 to the 3rd, it becomes positive. Y to the 3rd, z to the 15th. And then since this is a reasonably sized base and exponent, we're going to go ahead and evaluate that. So we have x to the 6th divided by negative 8, y to the 3rd, z to the 15th. Final answer. You were just watching that. Now you are going to, on your paper in the box that says practice 1, you're going to copy this expression, parentheses 3, a to the 4th, b to the negative 2, c to the 3rd, all of that raised to the negative 2 power. Press pause and come back to check your answer. Final answer, b to the 4th divided by 9, a to the 8th, c to the 6th. Let's look at my work. So negative 2 is applied to each of the factors. 3 to the negative 2, a to the 4 times negative 2 is negative 8, b to the negative 2 times negative 2 is 4, c to the 3 times negative 2 is c to the negative 6. 3 of those factors are taken to the denominator. 3 to the negative 2 becomes 3 squared in the denominator. A to the negative 8, a to the 8th in the denominator. C to the negative 6 is c to the 6th in the denominator, all over b to the 4th. All we need to do to fully simplify that is evaluate 3 squared, which is 9. So those were two examples where we just needed to use the power rule. Actually, we did all 3 things, right? We did the power rule, we moved negatives, and then we simplified. Next example that I'm going to show you, just another step here. And again, you don't need to write this down. y to the 8th, and then I'm first going to use that power rule. So x squared raised to the 2nd power is x to the 4th, y to the negative 3 squared, which is y to the negative 6th. My next part of my strategy is to move the negatives. So only this guy goes to the denominator. So I have y to the 8th, x to the 4th over y to the 6th. Quotient rule, that leaves me with y squared x to the 4th. Here is your next practice problem that you're going to copy onto your paper. So under practice 2, go ahead and copy this problem. Push pause, and then come back. Final answer, y to the 12th divided by x to the 13th. So what did I do here? Okay, so to start with, I just keep my x to the negative 5th, and then I'm multiplying that by x squared raised to the negative 4, which is x to the negative 8, and then y to the negative 3 raised to the negative 4, which is y to the 12th. The x to the negative 5th and the x to the negative 8, I'm moving down to the denominator. Final answer, y to the 12th divided by x to the 13th. Here is another example, and this is the most missed question, was similar to this on the quest. So I think the best strategy here is the arrows. X to the negative 3 is going to the denominator, x to the negative 8 numerator, y to the negative 2 numerator, y to the negative 4 denominator. So we have 10, x to the 8th went up, y squared, x to the negative 3 becomes x to the 3rd in the denominator, y to the 4th with that 2 still. So we're just simplifying. 10 divided by 2 is 5. X to the 8th divided by x to the 3rd is x to the 5th. Y squared divided by y to the 4th, we have y squared in the denominator. Now here we could have used that quotient rule. We could have done x to the negative 3 minus negative 8, which is x to the negative 3 plus 8, which is x to the 5th. We could have done y to the negative 4th minus negative 2, which is y to the negative 2, which is what we have right here. But again, most people that are trying to use just that subtracting a negative, we're making lots of mistakes. So I really think this arrow approach is the best one. Okay, we have 2 practice problems that you're going to go ahead and do on your paper, and then we are done. So copy practice 3 onto your paper, push pause, and come back. Oops. Practice 3, we should have a final answer of y to the 9th divided by 2x to the 7th. So the x to the negative 1 becomes x to the 1st in the denominator, x to the negative 5th, or y to the negative 5th becomes y to the 5th in the numerator. So we have 2, y to the 4th stays put, y to the 5th, divided by 4, x to the 6th times x, which simplifies to, we could have stayed with 2 y to the 9th over 4 x to the 7th, but then 2 divided by 4 simplified is 1/2, where we don't need to show that 1. Final practice in the slot on your paper. This is our most complicated one. Let's see what you can do. Practice number 4, copy that on your paper. 3x to the negative 4th times parentheses negative 4x to the 3rd divided by x to the 4th, y to the negative 5th. All of that last part raised to the negative 2. Press pause. All right. Oh my goodness. Final answer. 3 divided by 16x squared y to the 10th. Why did I do this problem? Let's check my work. Okay, so to start with, we keep 3x to the negative 4th, and then we raise the numerator and the denominator of this quotient to the negative 2. So negative 4 to the negative 2, x to the negative 6th, divided by x to the negative 8, because we have 4 times negative 2, y to the 10th, because we have negative 5 times negative 2. And then I'm just going to go ahead, I guess I didn't show my arrows, I'm going to move, oops, need some color. I'm going to move the negative 4 to the negative 2 to the denominator, the x to the negative 6 to the denominator, and then the x to the 8th to the numerator. That leaves me with this 3, and the x to the negative 4th here to the denominator. So I still have 3 in the numerator and just x to the 8th because the x to the negative 8 became positive when we moved it. We have x to the 4th, negative 4 squared, x to the 6th times y to the 10th. That stays in the denominator. Further simplifying, we have 3x to the 8th stays just like that. We're going to evaluate negative 4 times negative 4, which is 16. X to the 4th times x to the 6th is x to the 10th times y to the 10th. And then our last simplification is just making sure that we don't have two different x's in our expression. So x to the 8th divided by x to the 10th, we have x squared in the denominator. So this is my final answer. Okay, so now you're going to turn this paper over, do some individual practice, and then bring that into class to check your work with me. Thanks.